Hi. Exam 2 review. We are so enthusiastic about this, right? Yeah, let's do it. So, exam is in 2 days. And you said that it should be chapters 4, 5, and 6. 10 to 12 problems. And Z-score chart. Will be given. So that way you don't have to worry about that. Now Z-score and T-score chart will be given on exam 3, and then the final again, Z-score and T-score. You don't know what the T-score is yet because that's chapter 8. It's going to be equivalent to what the Z-score is just for the sample, but when we get there, right? So same deal as last time. We have the whole class for so hour 20 minutes for the exam, and if you so make sure you have your scientific calculator with you if you need one. What else? Just standard exam stuff. There's nothing special about this exam. Chapters 4, 5, 6, 10 to 12 questions. Some of those questions are extremely quick, as you've seen, right? And some will take a little bit longer to compute. I don't know. So what's on it? We have the three major areas. So number one is the probability. So probability, which is in chapter 4. We are talking about basic, joint, conditional probability, so basic, joint, conditional probability, and then we have probability rules, and we have at the end the independence, right? Well, probability rules actually include, so you have probability rules for addition and multiplication, so and or, right? So that's special, general, and that is. So we have a bunch of those. So rules of probability. I know I listed these and they're in your lecture notes and everywhere else, but it's okay to write again. So probability of the event is between 0 and 1. 0 means event cannot occur, 1 means event must occur, and then you have anything in between, like 30% chance of rain, which means 70% chance of no rain. That's pretty much what we have. Then we have the probability of the event A or B, and we have two of these. One of them is special, which is you just add these and you're done. But this one over here is only for A and B mutually exclusive, meaning they cannot occur at the same time. So that's a special one. And then we have the general rule, where you have your probability of A plus probability of B minus the probability of A and B which was the rule when you used it, right? You use that rule when the events are not mutually exclusive, and we did that with cards, and we did that with many examples in the class. So if you have any questions, we can address those as well. Raining and not raining, heads and tails, right? So mutually exclusive means if one is happening, the other one cannot happen, right? So mutually exclusive is always two events that cannot simultaneously happen. Also, if you roll a dice, right, you get one of the numbers. You can't get two of them at the same time. So it's either 3 or it's not 3. You can't get 3 and 4 or 3 and 6. Good. And we have the idea of negation. So probability that the event will not happen is 1 minus the probability that the event will happen. And this is what I said with rain and no rain, right? 30% chance of rain means 70% of no rain. So that's technically what it is. So these are our rules of basic rules of probability, and then we get to conditional probability, and the conditional probability was the one with a vertical line. That one was described inside the chart, right? The contingency table. So we learned about the contingency tables first, and the way to work out the joint probabilities and single probabilities. So for the contingency table, we said that on sides we have totals, over here we have cells, and the grand total. So that was the way the chart was given to us. And then we find whatever probability we need. For in all of the basic and joint probabilities, your denominator is always the grand total. And then for conditional probability is one of the marginal. Oh, these are called marginal totals. I should have said marginal totals. Let me see if I can fit that. Marginal totals. So marginal totals. So basic and joint probabilities, we have, actually let's do it, we can do it this way. So basic probability will be cell divided by, this is going to be GT, grand total, GT. Joint probability will be marginal total divided by the grand total. And then we have conditional probability, which was probability of A given B, which always had the probability of B here, and then whatever fits in here, which is a cell. They do give you the formulas to memorize, but I'm not keen on formulas. So probability of A given B is probability of A and B. So that's going to be a cell of some kind. And then probability of B is going to be some kind of marginal. So that's the chapter on probabilities as the one part. Number 2, we are going to the next chapter, chapter 5. And chapter 5 contains discrete random variable. So now we're talking about discrete random variable, then distribution of discrete random drv, right? Discrete random variable, which was the histogram, if you remember at all. And then we had the mean and standard deviation for these things. And we also did mean and standard deviation of drv and binomial distribution. That's a little star up there because the word problem, right? At least one. And in class we did a couple of them already. That was the time when you guys looked into what are the odds of guessing and passing exam that you have no knowledge for, right? So we talked about 10-question multiple choice. I think the rocket science or whatever it was, nuclear physics, whatever it was, doesn't matter. So randomly guessing 1 out of 4, where you can't even make an educated guess. So something is completely out of league, and you don't even know what to, right, where the educated guess. So you just circle whatever is given and you move along. And we saw that there was less than 1% chance to pass that exam with any grade higher than 70. So it was very, very tough to guess. If you have 10 multiple choice questions and each one of those has 4 possible answers, 1 is correct and 3 are decoys, right? So that was something that was very interesting to see. And then there were many other problems. So that's number 2. And the third part is this normal distribution. And this is where we had, so normal distribution, the first lecture was just assessing normality and talking about the bell-shaped curve and making sure that the data that you have is distributed that way. So the first lecture was just making sure that you have the data that you are supposed to look at. And then after that, we moved into working with these so area under, so now use Zscore chart to find, and here we go. What do we have? We have to find, I'm going to use pluses now. So to find the area given Z-score, to find Z-score given area, to find area to the right to find Oreo. Area in between two z-scores. Know that area equals percentage, so 0.2307 is equal to 23.1, let's say, percent. So to know that stuff, the z-score chart. Okay, compute z-score given x value. So we know that the z-score is equal to x minus the mean divided by standard deviation. This formula has been with us for 4 chapters now. So that's something that would be good. And I think that's it. Is there anything else that I'm missing? Yes? Okay, we'll talk about that, sure. Factorials are here. Yeah. Maybe if I did this instead of a star. That's where the factorials are in the binomial distribution. If you had that probability of x equals x, that was the n choose x probability of x failure n minus x. All right. Anything else? I think we covered everything, right? You have your z-scores and you have Yale. What happened?
How would you feel about letting us have a formula sheet?
Why would you want formula sheet? What do you? It's called learning. Okay, so if I give you a formula, what have you learned? Nothing. Like why even take the class? Just drop it.
Why did you discern it? Like, well, we don't have it on.
It's pointless. Yeah, exactly. Then you're reducing the class to like 2nd grade level. There's nothing to it. It was just think about it, right? It's the only thing that you are learning in this class are those few formulas. There's literally nothing else. Yeah, it's just a battle all the time. It's not a college issue. It's much before that, but let's not get into it. Yeah, that's all we're learning here. These formulas. All right, any questions on problems, concepts, ideas? Maybe we should do one of those educational homework assignments from socialist countries, because I come from one. Write each formula 50 times for homework for next class. That's yeah, it's the same thing. The goal of every socialism is communism. That's one of the Lenin. That's the first sentence of anytime you say something about Lenin, that's the first sentence. So yeah. No, that's just credit because in those countries only 10% get educated. Education is free, but only 10%. So that means only 3 students from this classroom get to go to school, and the rest of them don't. That's why the education is free.
Were you being serious about doing that assignment?
No, but I'm saying if that's going to help. If it's going to help, please do it, because that's what I that's what I have. Yes. Any other questions, concerns? Yes.
I have a homework problem.
Homework problem. Let's take a look at a homework problem.
Okay.
Oh, and you had the quartiles.
Yeah, is that going to be on the test?
You know what the quartile is. What is a quartile? First quartile. What's the first quartile? 25% of the data. So when data is given, you find the 25th percentile of the data, and that's your 25%. So for any given data, right? But you have to put the data in the. So first quartile is 25 bottom. Let's put the word bottom. So bottom 25% of data. So now, if you have a 25% of data, yes.
I only have the mean and the standard deviation.
Okay.
So what do I do then?
So what does it say?
It says, according to a recent study, the lengths for adult males of a certain species of tarantula are normally distributed with a mean of 18.06 millimeters and a standard deviation of 1.98 millimeters. And then complete parts A through B.
All right. So we have the mean and we have the standard deviation. So if I draw the standard curve, which is the bell-shaped curve, we are going to have our 1806 in the middle, and then 3 standard deviation one way, 3 standard deviation the other way. Now, if I transfer, so this is my x-axis, right? And I can add 198 and subtract 198 to come up with other values. Now, the same line becomes, in red, becomes 0, 1, 2, 3 on a z-scale, right? And 25% of the data is going to be 25% of the area under the curve, and the 25% of the area under the curve will have the area over here equal to 0.25. So now we can find the x value. So we have area, and then we can I'm not sure why I'm so dramatic. Area will give us the z value, and z value will give us the x value that we are looking for. So now we're going to go into the Z-score chart at the end, and I'm going to look at the chart and find the Z-score for 25. So now I know that area is 0.25. So what Z do I get for that? So now you have to look at the Z-score chart, which I have over here. And for this, this is the, I always have to remember which software I'm using because one of them allows for this and the other one does not. Okay, so here we go. You have your areas. Somewhere in this mess of numbers is 0.25. Where is it? Well, 0.14, 0.16, 0.12. Oh, there you go. 4825. So this one is 2483. That's 17 away. And this is 14. That's 14 away. So this is the better one. It's closer. So we'll use that one, which is this number, negative 067. Negative 067. So negative 067 is the z-score that corresponds to the first Right? So that's the z-score corresponding to the first is negative 0.67. And then, once we have the z-score, we have the formula that the z-score is equal to x minus mu over sigma. You have all of these values. You know that your this sigma, holy nightmare, come on. There we go. So now z-score is negative 0.67, x is unknown, the mean is given as 1806, and your standard deviation 198. Cross multiply, add 18, and you're done. So we have I'm sorry?
16.78.
Thank you. 16.78. 16.78. So it was male something, whatever. Size of the tarantula, you said? So 25% of all male tarantula are smaller than 16.78 millimeters. So 25%, and this is the sentence that you're actually getting points for. So 25% of male tarantula are smaller than 16.78 millimeters. And that would be the answer that you are providing in your report. I mean, yes, you say exam, but this is extremely applied. So this is what we have. And this is a really good problem, because it kind of covers everything, right? You're starting, and it also brings up the knowledge of quartiles. So you have the first quartile, 25%. Second quartile is what? Half, which is mean. And what's the z-score for that one? Area is 0.5. What's the z-score? 0, exactly. So mean has the z-score of 0. And then your third quartile would be 75%, so you're looking for the 75 to the other side. And that's that. Great question. Anything else? Yes?
I don't like double owners of conditional and probability involving cards. So, for example, the probability that you would take a card inclusive from 7 to 10.
Okay.
Given
Pick a card 7 to 10 inclusive, given
it's not a spade.
okay, not spade. Great. So let's talk about this one. Well, first off, we would like to count all of the possibilities that we have. So we have 4 suits, right? One of them is spade, and that's the one we don't want. Now, 7 to 10 inclusive. We have 7, 8, 9, and 10. All right, so here they are, all of them. So we are picking from the entire deck, right? So we are picking from the entire deck, and the entire deck has 52 cards. So what is the probability to pick this? Wait, given that it's not a spade. Ha. Yeah, nice. I like it. We get to think here. So you want to pick only these, making sure it's not a spade.
Did we use the formula probability A and B divided by probability B?
Yeah, but we need to set it up. That's the formula, and if you can argue your way through it without a formula, that's fine as well. It's just that I'm constantly flipping it in my head. So pick a card, 7 to 10 inclusive, given that it's not a spade. So this would be our Is it the whole deck? That's what's messing me up. Do you have the whole deck, or you just have? Yes, because it's not given no spades, right?
39 cards.
So, yes. So 39 cards because you have no spades, because the spades are 13 cards. 52 minus 13 is 39. So I'm still having trouble to write this part here, but it's going to be these 12 out of 39. Because these are the cards they want, so they don't want this, right? They don't want that. Given that it's not spade, so not spade. It's a terrible. You draw upside down heart. There we go. And what should I put here? I don't know, 7 to 10, whatever. We can define these probabilities on a side and then call them A and B. But so it'll be 12 out of 39 because you are looking for one of these 12 cards under condition, right? You are taking out spades. So whatever you are say given, whenever you say given, that defines the entire universe from which you are picking. So if you say given red cards, then the black cards don't exist. And nothing else for that matter exists. So when they say given not a spade, that means all 3 other suits are there. And that's going to be 13 times 3 for 39 cards, because each suit has 13 cards in it. 1 through 10, and then Jack, Queen, and King. So 13 cards times 3. Good. Yes? Inclusive, that includes 7 and 10. When it's not inclusive, then it's just 8s and 9s. That's just the open and closed interval for numbers. That has nothing to do with mutually exclusive or anything like that. That's a
7 to 10 exclusive. What would it?
Just 8s and 9s, so it will be 6 over, because you would only have these ones in that case. I saw one more hand over there somewhere. Yes?
I was just going to ask, when doing this, you brought up the probability of A and B over the probability of B. So would you have to divide that by the probability of not spades, or no? That's just your answer?
Well, you can in that case, if you want to use the formula, this would be just 12 out of 52 divided by 39 over 52, and 52 is canceled, because there are 52 cards all in total. Yes?
Do you prefer F of n, or does it matter, like, if you use formula or F of n?
Whatever gets you the right. Because as I said, when you start working, people are only interested in the sentences and analysis. No one cares which way you, right? In your written reports for companies and things, they only read in the words. They don't look at the calculations. Those are not included.
So if I put no work in the right answer, I get one.
Yes.
Oh.
Not all of them do. Yes.
Do you have a project in this one?
For the last 3 months, yes. See? Good thing you showed up, huh? I'll see you all.